Okay, so we're going to try to look at how we can determine the unit tangent vector t, the principal normal vector n, the curvature k, as well as the binomial vector b given space curve. Okay, um, so we'll look at some few examples to try to make sure to say we become very familiar with how we determine these four, which is the t, the n, the k, as well as the b. Yeah, so look at some few examples. So the first example that you're going to look at is let me name this as my a. uh, I'll say rt there is equals to um, so let's say we have cos t plus t sine t. Okay, uh, in the I there plus say open bracket again, we have sine t minus t cos t in the j. Okay, so we what else? I think we can also add. Let's say we have a 3k. Okay, we have a 3 unit in the k. Okay, so first of all, I'm starting with finding the unit tangent vector, which is my t. So what I need to do here is that what I need is I need to find the first derivative of that vector valued function. So the first derivative is if we differentiate this part, we are going to get that to be minus sine t plus, this is a product of two functions. So if let's say here we maintain t, okay, we maintain t the way it is, then we differentiate sine, that will give us cos t. Then we maintain sine, we differentiate t, that will give us plus what? Plus sine t, okay, in the I, plus this part we're going to have cos t, that will be minus t. In fact, I think this is going to be a plus because you're going to have like this is more like it would be in the brackets there. So when you differentiate this part, you're going to get plus t sine t minus cos t in the j. Then of course this is a constant, you're going to get a 0. Okay, so now we observe to say this part we get a 0, and that is a 0. So like we have minus sine plus sine, we have positive cos and negative cos. So what I remain with is what is my t cos t in the I, okay, then plus t sine t in the j. Okay, so and I think it's wise enough for me to find the magnitude in advance. Okay, so the magnitude of the first derivative, uh, we say, so this is going to be like you're going to have your t squared, because you're going to square this part. You're going to have your t squared multiplied by cos squared t plus, that would be like t squared sine squared t. Okay, so you can factor out the t squared, of which this is going to appear to be something like you're going to have your t squared open bracket cos squared t plus sine squared t there, of which we know that that's a 1. So we just end up with having a root of t squared giving us a what? Giving us a t. So meaning the absolute value is uh, the magnitude, rather, the magnitude is simply what? A t, like that. Okay, so these are the two important things that I need to start with for now. Okay, can put them there. So now for me to determine the unit tangent vector, we can say the unit tangent vector is expressed in this form, as t, like that, meaning you are evaluating at t. There are times when your t is given as some value. Okay, that will be equals to your first derivative there with respect to t divided by the magnitude of that first derivative, which we already found. So in this case, this that we found, what we found that, so we just write it the way it is as our t cos t in the I plus t sine t there in the j, divide by we say divide by that's divided by t. Okay, but we observe to say we are able to factor out the t there. Okay, so of which is going to cancel out with the t that we have on the denominator, meaning the t, the unit tangent vector is simply equals to uh, cos t in the I plus um, sin t in the j, like that. Okay, so even this one, I believe I'll need to use it. So what I want to do is that I have to find the derivative of that. So the first derivative of that is going to give me that's minus sin t in the I plus cos t in the j. Okay, that's my first derivative. So I think I also have to find the magnitude of that. So the magnitude of the first derivative of the unit tangent vector is going to be equals to a 1, because we're going to square everything that we have. This is going to be um, that's going to be a positive, because there's a negative, going to be positive sine squared t plus cos squared t. This is a 1. Okay, so we find that the magnitude is just what? The magnitude is a 1. So we have a 1 here. Okay, so now we have found what our unit tangent vector, which is right here. Okay, so now what about the principal normal vector? So the principal normal vector, which we indicate as that evaluated at t, it is equals to the first derivative of the unit tangent vector divided by the magnitude of the first derivative of the unit tangent vector. And we found that the first derivative is minus sine t, okay, plus cos t. Of course, this is j and this is I. So divide by what? Divide by the magnitude, which is found as 1. So meaning the principal normal vector is simply equals to um, uh, we find that it's equals to minus sine t. We have I there plus um, cos t with a j there. Okay, so now what follows is that we need to find the curvature there. So our k is equals to the magnitude of the first derivative of the tangent unit tangent vector divided by the magnitude of our first derivative of our vector valued function, which is our r. So in this case, uh, the magnitude that I found for the unit tangent vector was equals to 1. Okay, divide by, then the magnitude of that part, what we found is that it was equals to what? It was equals to t. So that is what our curvature is equals to t there. Okay, so we can say our k is equals to 1 over t. So the last part that we have to find is that we have to find the binomial vector b. Okay, so the binomial vector b is simply equals to the cross product of the unit tangent vector by the principal normal vector. Okay, so we're going to have our I here, then j, k, like that. Okay, so the j component of our t is minus sign. Is it minus sign? Okay, that's um that's a positive. Okay, it's cos. I almost got the one for the first derivative. It's this part here. Okay, so it's a cos t, then the j component is sin t, then the k component is 0. Then for n, okay, for n the I component is minus sin t, the j component is cos t, the k component is 0. So you end up finding that when we do the cross when we cross these, we are going to have 0 in the of I. Okay, 0 of I plus 0 in the j. Okay, then you're going to have plus some value for k, because k is simply this one times this one. That will give us cos squared t. So it's like you have our cos squared t minus this one by that one, supposed to be negative, but because of that negative is going to multiply by that would be by this one is going to be positive, so that would be like sine squared t, which is simply a 1. So it would be like 1k, or I can just indicate as k. So meaning the the binomial vector is just equals to 1k or just k. Okay, so that's how you go about that question. So let's try to look at another example to make sure to say we are very familiar with how we take care of or how we answer such questions. So let's say let me call this a b. uh, we have our vector valued function rt is equals to uh, t to the third divided by 3. Okay, that's the I unit. So plus t to the second divided by 2. That's j there. We don't have a k component. So the key thing here is that I know for sure I have to first of all have to find the first derivative. Okay, the first derivative is simply nothing but that will give you t squared in the I plus t in the j. Then the magnitude of that, what you're going to get is the square root. That's supposed to give you t to the fourth plus t squared. But I'll simplify this and I'll just write it as t root of t squared plus 1. Okay, so what I wrote earlier and this is simply one and the same thing. So meaning my unit tangent vector, that will be equals to uh, my first derivative, which is t to the second of I plus t of j divided by the magnitude, which is uh, t squared plus 1. So if we simplify this, what you're going to get is you're going to get ti plus j divided by square root of t squared plus 1. So that is our unit tangent vector. Our unit tangent vector, we have found that is what? T in the I plus j divided by the square root of t squared plus 1. So what follows is that I know I have to find in advance the magnitude of that. So, but before I find the magnitude, I have to find the first derivative. So the first derivative is going to be equals to when we differentiate that which we have. So this part here, when it comes to differentiating, you can simplify it for yourself. Like try to write it in a way that's such that it's convenient for it to differentiate. So I'll write it as ti, since like it's more like ti as well as j. They have a common denominator, which is square root of t squared plus 1. So that would be like plus j divided by the square root of t squared plus what? Plus 1. Okay, so when we differentiate, after you differentiate, you're going to find that the first derivative will be equals to it's going to be equals to something like um, 1 over t squared plus 1. Then I'll raise this to 3 over 2 minus, in fact this is in the I, minus t divided by that's t squared plus 1 to the power 3 over 2 in the j. That's the first derivative. Okay, so we just have to write it somewhere here. I'll write it somewhere here. I think we need to use it at some point. Okay, so that's what we have found there. That's 1 over that's t squared plus 1 to the power 3 over 2 minus forgot something here. It's supposed to be I, then minus 1 over, in fact that's t, yeah, t over t squared plus 1, that's 3 over 2 in the j. What about the magnitude? Of course we need to find the magnitude, because for us to find the principal normal vector, we have to have the magnitude as well. So the magnitude of the first derivative of the unit tangent vector, when you find the magnitude of this, you're going to arrive at something that will appear like it will be something like t over t squared plus 1 to the power 3 over 2. So try it out. The magnitude of that is supposed to give you something like that. Okay, so now we can say the principal normal vector will be equals to The principal normal vector is going to be equals to um, this part here divide by what you have there. So we are going to first of all write it the way it is. I'm going to say 1 over t squared plus 1 to the power 3 over 2 in the I minus t over t squared plus 1 to the power 3 over 2 in the j. So we are dividing by what? Um, Dividing by that. So that's like t divided by t to the power 2 plus 1. That's 3 over 2 there. So when you simplify that, your your principal normal vector will give you something like 1 over t in the I minus j. Okay, that's what you're going to get. So we say it is equals to 1 over t in the I minus j. Do we really need to find the magnitude? No, we don't need to. We will not need to use it at any point, so no need of finding the magnitude of that. So what about the curvature k? This will be equals to um, this is going to be equals to the magnitude of the unit tangent vector. The magnitude that we found was what was the magnitude? It was something like okay, the magnitude of the first derivative, it was something like t over uh, t squared plus 1 to the power 3 over 2. Yeah, something like that. So we are going to write that. So that will be like our t divided by t squared plus 1 to the power 3 over 2. And we are dividing by the magnitude of what you have here. There, so the magnitude is what? The magnitude is that one there, which is t, okay, root t squared plus 1. So when you try to simplify that, you're going to arrive at 1 over uh, t squared plus what? T squared plus 1. So that's our k. So our k is 1 over t squared plus what? T squared plus 1. So the last part that you have to find for this question is the binomial. And when I say the binomial vector is equals to the cross of t by n, of which we can write as, we have our I, then we have our j, and we have our k there. Okay, so this the I component of t, okay, it's 1 over um, is it 1 over okay, so the t that we had found was yeah, this is supposed to be t actually. So it's supposed to be t. So that's the I component is going to be t divided by root of t squared plus 1. Then the j component is going to be 1 over uh, 1 over 1 over root of that's t squared plus 1. Then the k component is 0. Then for the n has 1 over t, then with a negative 1 there, then we have a 0. Okay, so our binomial vector b is going to be equal, so we're going to have a 0 in the I, 0 in the I plus 0 in the j. Okay, 0 in the j. Then in the k, you're going to have I'm going to say plus open bracket, this is going to be minus t over root of t squared plus 1. Okay, then you say minus t multiplied by that is like 1 over t to the power, I mean 1 over t multiplied by root of square root of t squared plus 1. Okay, so this is the k component of it. So I can leave it in this form. You can try to break it down to see what you're going to end up with. Okay, so let's look at the last example of in this video. uh, let's say we have Now for this one is evaluated at some number. Okay, let's say our vector valued function rt is equals to t squared in the I plus t to the power 3j minus tk. Okay, so we are evaluating at t is equals to 0. So the first thing first, remember first derivative, it will be equals to that would be 2t in the I plus 3t squared in the j minus k, like that. That's the first derivative. Then the magnitude of that when you're going to write it like this, that would be like 4 squared t plus 9t to the fourth. That would be plus 1. That's a negative. Then when we square it, it becomes negative 1. So everything there, remember to say the way it is in this manner. Like I have it as a t and another t here. So it's like when I replace with t, like I'm evaluating at t is equals to 0. That's the magnitude, by the way. That's just going to remain as the square root of what? Square root of 1, which is just what? A 1. So the magnitude is 1 there. So meaning our t, our unit tangent vector is going to be equals to our 2t in the I plus 3t squared 3t squared in the j minus k, then divide by 1, which is the magnitude. So that's just going to turn out to be our unit tangent vector. Okay, so we can say it's 2t in the I plus 3t squared in the j minus k. Okay, so if you want to evaluate this at 0, okay, at t is equals to 0, so that is going to give you're going to have a 0 here and you're going to have a 0, so that will just give you minus k. Okay, so when you evaluate that, so I also have to find the first derivative of that. So the first derivative of the unit tangent vector is going to be something like you're going to get a 2i plus 6t in the j. Okay, so then what about the magnitude of the first derivative? That's supposed to give us something like 4 plus that's 36t squared. But if you evaluate the magnitude or the first derivative of the unit tangent vector at t is equals to 0, that's supposed to give you what? Give you a 2, because when you place here that would be a 0, then square root of 4 is simply a 2. Then going to the principal normal vector nt, that would be equals to the first derivative of the unit tangent vector, which is 2i plus 6tj divided by the magnitude, which is a 2. So when you simplify that, that's just going to be I plus that's a 3tj. That is our normal. Okay, so I found that our principal normal vector is equals to I plus 3t in the j. So if you evaluate it at t is equals to 0, you're just going to remain with the I there. So that's that. Then for the curvature k is equals to, that will be equals to the magnitude of the first derivative of the unit tangent vector, which we found as uh, a 2. Okay, this one here, I'm going to take the one that I evaluated at t. Then the magnitude of this one, we found that it's 1, so our curvature is just equals to 2. Okay, so what about the last part, which is the binormal vector? So the binormal vector, we remember that it's just t cross n, and that will be equals to sorry, like we have our I, we have our j, and we have our k. Okay, so the I component of the t, the I component of t is a 2t. Okay, um, the I component is 2t there. Then the j component is a 3t squared. the k component, um, the k component that we have is a 1. Okay, the k component that we have is a negative 1. Okay, so I'm getting from this point here. Then the I component of n, the I component of n is a 1 itself. Then we have 3t, then we have 0 there. Okay, so now if we cross those, we are going to have in the I, I'm going to have negative 3t in the I. Okay, that will give us a 0. In fact, that will be a positive, not negative. So this is going to be a positive, because you're going to have minus what you have there. That is going to be a positive. Then in the j, this is supposed to be a minus 1, but that's just going to be, in fact, it's supposed to be minus whatever that I have here. So since what here I have negative 1, that has multiplied with this one to become negative 1. So I mean to become positive 1, that will remain as what? Remain as negative 1, but I'll just indicate as j. Then in the k, we have 2t by 3t, that will give us 6t squared minus 3t squared. So that will give us, like, we have 3t in the I minus j, that will be plus 3t squared, and that is our b. Okay, so that's how you go about finding the unit tangent vector, the principal normal vector, the curvature k, as well as the binormal vector. Thank you very much for watching.